When multiplying a rational expression, you need to simplify each fraction down to their simplest form. So here in my first fraction, I have 6n plus 60 divided by n squared plus 12n plus 20. So for my numerator, my 6 and my 60 both have a 6 in common. So I'm going to divide both by 6. This 6 will be in front, leaving me with n plus 10. In my denominator, I have a trinomial, so I'm going to factor that using the British method or the box method. So when I factor, I get n plus 10 and n plus 2. Now when I move over to my second fraction, I'm going to do the exact same thing. So I have a trinomial again in my numerator, so I'm going to factor that using the British method or the box method. When I factor, I get n minus 7 and n minus 2. In my denominator, I have 6n subtract 42. Both of those terms can be divided by 6, so my 6 is going to go in front, leaving me with an n subtract 7 inside. Now I'm going to treat this as one giant fraction, and I'm going to cancel in pairs common factors that are in the top and the bottom. The factors do not have to be in the same original fraction. They could be in two different ones, but as long as the factor is in the top and the bottom of our fraction, we can cancel them. So I'm going to cancel out my 6's. I'm going to cancel out my n plus 10. I'm going to cancel out my n subtract 7. So that leaves me with an n subtract 2 in my numerator and the n plus 2 in my denominator. When multiplying a rational expression, I need to simplify each expression or factor each expression. That way I know what is in common between the numerator and denominator. So I'm going to go one fraction at a time. So I'm going to start with my first fraction of 4k plus 36 divided by k squared plus 6k minus 27. So in my numerator, I have a 4k and a positive 36. Both of those terms can be divided by 4. So I will have a 4 in front, and I'll have a k plus 9 left over. In the denominator, I have a trinomial, so I'm going to factor that expression using the British or the box method. When I factor, I'm going to get k plus 9 and k subtract 3. Now I'm going to move over to the second fraction of the k squared minus 5k plus 6 divided by 4k subtract 8. And I'm going to do the exact same thing as I did in the previous fraction. Since my numerator this time is a trinomial, I'm going to factor that expression using the British or box method. When I factor, I get k subtract 3 and k subtract 2. My denominator, I have 4k subtract 8. Both of those terms can be divided by 4, so my 4 will go in front, and my k subtract 2 will be left over. Now that I've simplified both of the original fractions, I want to think of this as one giant fraction with everything in the numerator and everything in the denominator. I want to cancel out the factors that are in common in the numerator and denominator. They do not have to be in the same original fraction. One just has to be in the top, and the second has to be in the bottom. So I'm going to cancel out the 4's. I'm going to cancel out the k plus 9. I'm going to cancel out the k subtract 3. And I'm going to cancel out the k subtract 2. So everything canceled out. I am left with no factors. So this would leave me with a value of 1. It does not leave me with a value of 0. It will always at least simplify down to give me 1.